Hello everyone, I am Ubaid Imtiaz and I am doctoral candidate number 10 in the NEPIT project at Eindhoven University of Technology in the Netherlands. I am doing research on effectiveness of shielding covers in reverberant environments. The electromagnetic spectrum is very complex and full of interferences at different frequencies from different sources. Whenever an electronic product is designed and launched in the market to be used either by common people or for industrial applications, it is of interest to the designers and also a legal requirement that it neither disturbs nor is disturbed by other electronic products coexisting in its vicinity, sharing the same electromagnetic spectrum. Think of a GSM cell phone causing interference in video signal of a television or a flicker of a tube light when a heavy load such as a hair dryer or a water pump is turned on. We all must be very familiar with these. These things are now kind of relics of the past thanks to the wonderful EMC engineers that ensure these do not occur anymore. But as the world progresses and newer technologies and concepts such as Internet of Things and 6G take the center stage, the electromagnetic spectrum keeps on getting more and more dense and complex. And naturally, a need has arisen to look for newer ways to ensure no electromagnetic interference occurs. One such way to make sure that a piece of electronics does not interfere with its neighborhood, electromagnetically speaking, is to put an electromagnetic shield around it. An electromagnetic shield is nothing but a simple metallic box that makes sure minimal interference passes through. I say minimal and not zero because there are yet signals of interest alongside unwanted interfering signals that we want to pass through the shield. Think of a remote controlled toy car and an electronic wheelchair in close proximity to each other. We want the signal from the remote control to reach the toy car while at the same time suppressing that signal to not disturb the function of the electronic wheelchair. Now, these metallic shields may seem simple, but there are multiple caveats to their optimal design. A measure of assessing performance of a shield is called shielding effectiveness. Shielding effectiveness of a shield is measured by placing the shield in between a transmitter and a receiver and comparing the signal received at the receiver with the signal that would have been received at the receiver if there was no shield present. This signal that received at the receiver in the absence of the shield is called a reference signal. This procedure of measuring shielding effectiveness is made free from all the interferences and reflections by conducting this test inside a specialized room called an anechoic chamber. Although there are multiple problems with this approach, but we will focus on the most obvious one, and that is that the real environment is not free from all the interferences, but instead it is full of interferences and reflections. Instead of being anechoic, the real environment is highly reverberant. This is where my research comes in. Instead of measuring shielding effectiveness in an anechoic chamber, my research focuses on conducting this and many other EMC tests in a reverberation chamber, which rightly exposes the equipment under test, which is in this case a shield, to a highly reverberant environment, which is more representative of the realistic environment. So, this assessment then would give us a more realistic view of the performance of the equipment under test. This, of course, comes with added advantages of low cost and very less testing time than the anechoic chambers. My job is to research and extend the already established testing methods for shielding effectiveness in reverberation chambers and come up with methods to perform this testing in situ. Think of a large equipment such as an aeroplane or a ship which cannot be brought to a test lab. Instead, the test lab has to go to the equipment. Hopefully, with this, I have sparked some interest in your minds for the complex world of EMC and shielding effectiveness. Thank you for your attention. If you are interested to know more about my research or the NEPIT project, scan this QR code.